Hey students, welcome back. This video we're going to cover Module 8, Topic 6. This is going to finish out Module 8 for us. This is page 16 of the Module 8 packet. So like I said, this will finish us off. It's pretty quick, just 2 pages, so front and back. Just going to go over the last few things. This was parts of similar triangles. So, I mean, we've talked about, anytime we talk about triangles, we talk about the sides and the angles, and this is going to be the other parts. Altitudes, angle bisectors, and medians, you'll see below. Let's see. So again, page 16, let's just get started. I'm going to scooch up here. Warm up, solve for x. So we're going to cross multiply. So here you got 8x, 8 times x is 8x, and then 12 and 2 make 24. 8x equals 24, and this is just good algebra practice too. Divide both sides by 8, and x is going to equal 3. All right, I'm going to do the same thing at number 2. 12 and 3 is 36. Then 8 times x plus 2, so 8 times x, 8x, positive plus 2 times 6 makes 16. Subtract 16. I'm going to take it over here. So 36 minus 16 is 20. 8x comes along for the ride, and these guys cancel out. So we got 8x equals 20. Divide both sides by 8. And x is equal to 2.5 here. All right, number 3 over here, they have us set it up for ourselves, so we have these 2 parallel lines. I'm going to start with x. So x is down here on this side. Let's see. We go x over 4, and then 2 over 3. I go 2 because that's where x was. You got to make sure you're keeping things straight. So 3 times x is 3x. 4 times 2 is 8. Divide both sides by 3 because 3x is equal to 8. And x is equal to 8/3. You could also divide 8 by 3 and get the fraction, but I mean the decimal, but I'm good with the fraction here. All right, scooching down. Parts of similar triangles. Again, still page 16. Yeah, finishing off Module 8. So parts of similar triangles, Theorem 8.9. If 2 triangles are similar, the lengths of the corresponding altitudes, so altitudes over here, are proportional to the lengths of the corresponding sides. So symbols here. Similar triangles have corresponding altitudes proportional to corresponding sides. Let's see. Give me 1 second. Just got to regroup here. Okay. Sorry about that little side disturbance. Okay. So, similar triangles have corresponding altitudes proportional to corresponding sides. So over here, if XYZ, so this guy is similar to RST, this guy, then YW, that's that altitude, is going to be proportional to that altitude. And then they just pick this side, YZ, is going to be proportional to ST, excuse me. All right, that's Theorem 8.9. So Theorem 8.10, 2 triangles are similar. The lengths of their corresponding angle bisectors. So this bisects that angle, this bisects this angle. Those are going to be proportional to the lengths of the corresponding sides. And, same. So symbols here, similar angles. Similar triangles have corresponding angle bisectors proportional to corresponding sides. Try to use some of these symbols with you guys too. I use some of them from time to time, but I'll try to start using more. So example, so DEF, if this guy is similar to this guy, then EW, that's that angle bisector, is going to be, so this angle bisector to this angle bisector, and they have DE, so they pick this side to this side, but they have to be corresponding sides. So top left here, top left here. Excuse me. All right, scooting down the page, I'm just going to go ahead and put the rest of this so we can talk about it and move on. Theorem 8.11. If 2 triangles are similar, the lengths of the corresponding medians, that's the median, are proportional to the lengths of corresponding sides. Similar triangles have corresponding medians proportional to corresponding sides. So over here, PQ, PQR, FGH, then RS, that's this one. So this one over this one to pick a side, PQ to FG. But notice it was the whole thing to the whole thing, not a half and a half. All right, an angle bisector of a triangle also divides the side opposite of the angle proportionally. All right, so 8.12, so now we're talking about angle bisectors, but we're talking about how it affects the side here. An angle bisector in a triangle separates opposite sides into two segments that are proportional to the lengths of the two other sides. So let's see, give me just a second. Excuse me. All right, so opposite side into two segments that are proportional. So it says if AP is the angle bisector, I'm just gonna, if I could pick up this crazy pencil. AP, that's your angle bisector of ABC, this triangle. Then BP, so BP over here, and CP, so BP over CP, so it splits this side. So this side is going to be proportional to this side in the same way that this side and this side. So like the isosceles triangle. But yeah, so let me just do it in colors. So BP to CP and BA to CA. That kind of messes that up because of the, but you guys get the point. This to this to this to this. Well, we'll flip over at page 17. That's going to be the last page of the packet, and we're going to do a little bit of practice for this. Keep my notes. I'm going to keep them so you can see them, so we can refer to those to solve. Move the camera, get us situated. Again, page 17. Number 1, top left. Well, where did the page go? Okay. In the figure, triangle MNP. This guy is similar to XYZ. This guy, find the value of X. So let's draw in some of this stuff here. So we got an angle. These two are congruent. And this is a median. So those two are congruent. It splits that side. Okay. And what else do we have here? I'm just gonna do this, the one in the middle, because those are where those numbers are associated with. So we're gonna have 18. So the two medians here, 18 to 27, is gonna be. So if these two are the same, these two are the same. It's gonna be. Actually, we'll just say if this is X, this is X, this is 12, this is 12. We're gonna say. Where did we start? We started here. So 2x, not just x, but 2x over 12 plus 12, which is 24. Then we cross multiply. 27 times 2x is 54x. And 18 times 24 is 432. And if we divide both sides by 54, we're going to see that x is equal to 8. So 18 to 27 is going to be the same as it either be 8 to 12 or 16 to 24. Either way, we would have gotten the same thing. But I prefer to do it, kind of teach you guys a certain way and be consistent with it. It kind of helps when we're discussing it, and if I'm looking at your scratch work, then I know what I'm dealing with. All right, number 2. The pair of triangles are similar. So it tells us they're similar. What's the value of x? And, you know, I talk about this a lot, and I circle this stuff, and then I won't talk, so let me do both. Always make sure you know what you're being asked. That's the first thing with math here. We need to know what exactly we're being asked and what exactly we're being told. So we're being told these two guys are similar, so all those rules apply. Now solve for x. So we're going to start with the little guy over here. X on top. To 22 because that's the angle bisector or the median. And then here, we're going to add it just like we did here. So we started with the little, we're with the little. 5.25 and 5.25 make 11.5. 7 and 7 make 14. Cross multiply. 14 times x is 14x. Oh, that's 10.5, not 11.5. Oops, almost made a mistake. Okay. And then 10.5 times 22 is 231. Check this math. Hold on. Okay, 231. All right. Divided by 14. Just checking. All right, so divide by both sides by 14, and in this case, x is going to be equal to 16.5. Okay. All right, moving down. Two more here, just number 3 and three more. Number 3, number 4. God, anyway, we got 4 more. 3 through 6. God, I kept looking, and every time I looked down, I had another problem down there. I'm just going to kind of do a little working ahead here with my... Okay. Bring this over here. All right, number 3. A digital camera projects an image through its lens and onto its sensor where it's converted onto a digital image. The distance between the camera's lens and its sensor is known as the focal length and is adjusted depending on the size of the object being photographed. And its distance from the camera lens of an object being, and its distance from the camera lens. Okay. Miss Eglin sets her camera up 3 meters away from her subject, who is 1.6 meters tall. The sensor of her camera is 4.6 millimeters tall. What is the optimum focal length? All right. Let's see. So what we end up with is 2 triangles. I'm going to try to draw them the best I can. You guys know I'm not really a drawer. Let's see. So we got to do some converting. We have millimeters here and we have meters. So 4.8 millimeters is 0.0048 meters. Because we go from meter to centimeter, we have to go all the way down, and that's how many. So our, let's see, let me look here, 3 meters, so this is 3. And then the focal length we're going to need to know is x. And then she's 1.6 tall. The camera, the sensor on the camera is that tall, so it's 0.0048. So we're going to go x to 3, 0.0048 to 1.6. So x to 3, and then 0.0048 to 1.6. And then we cross multiply. 1.6 times x, 1.6x. 3 times 0.0048 is 0.0144. So now we're going to divide both sides by 1.6. And when you divide 0.0144 by 1.6, we get hang on, let me see which one, because I've already, hold on one second. So you get 0.009. So x equals 0.009. Well, we moved the decimals over. So it went 1, 2, 3. 1, 2, 3. We go put the 3 back. So 0.009 is also, that's meters. or it's also 9 millimeters is what the focal point, which we would go little anyway because we're talking about this little camera. Hopefully I didn't lose you guys through my rambling. All right, number 4. Traffic enforcement. So a police officer is determining where to park his vehicle to observe traffic at the red light. So if AC down here is 512 feet, and RP is 384 feet, and Y, Lord, I can't even see, Y is 201 feet from B, so that's B right here, that's Y down here. How far is Z to Q? This, let's see. Just a second. And this is Z here, and this is Q. No, that's Z. That's Q. So this is gonna be X. This is 201, and it's gonna be X to 201. This to this, because that's how our proportions go. The median to the median, the side to the side. So X to 201, 384. To 512, and then we cross multiply. 512 times x is 512x. 201 times 384 is 77,184. So 512x equals 77,184. I'm going to divide both sides by 512, and Mr. X equals 150.75. So that's how far this is. Their drawing's a little off because, looking at it, I don't see it being, that looks a lot shorter than 50 something feet. But, that's why we go by the math. We don't go by the looks. But I've also told you guys, when you can use your eyes and say, this doesn't look right, in this case, we're not worried about it. All right, number 5. Bottom left, last page, page 17. Find the value of X. So X is here. This is the whole side, and they tell us this one side's 12. So we're going to have JG. So this guy to GH. So one side to the other. Give me 1 second, guys. Give me one. Okay. So this side to this side. Remember the... excuse me. Yeah, the angle bisector makes the opposite sides in ratio to those sides. So GH to GJ to JH. And it's going to be, so we started over here, it'll be FG to FH. So, yeah. So we have 12 to 12 minus X. I remember earlier I tried to mess up. That's because the whole thing's X. This is 12, so this is 12 minus X. And then FG is 30, and FH is 25. Now we cross multiply. We'll start up here. 12 times 25. Where am I at? 30X. Yeah, so 12 times 25 is 300. 30 times 12 is 360, and negative x times 30 is negative 30x. Yes, that's right. All right. So since we got a negative here, we got a big number here and a small one, we can go negative by negative and end up with a positive x. Just follow me. We're going to subtract 360 from both sides. Those cancel. We have negative 30x is equal to negative 60. Divide both sides by negative 30. And x is going to be positive 2 because the two negatives. Actually, hang on a minute. Hold on. I'm sorry. I'm looking at last year's notes. Minus 360. 30x minus 360. Duh. It's x minus 12, not 12 minus x. I wrote it. I did it backwards. God, I couldn't figure out what the heck I did. Sorry, guys. Let me just rewrite this real quick. So that would be 30x minus 360 equals 300. And then we add 360 to both sides. And you get 30x. These cancel. 30x equals 660. So we're dividing 660 by 30. X equals 22. Sorry about that. So if the whole thing's x, this is x minus 12. Or this is x minus 12. Sorry. Goodness. Okay. Number 6. Last of module 8. Find the value of x. So we got an angle bisector here. So these two sides are going to be in proportion with these two sides. So the whole thing, how did we do this? I don't know that I like the way I did this last year. Hold on, I'm going to pause a second. Okay, sorry about that. Yeah, last year I did a little different, and I was just double checking some stuff. So, because we get a little confusing, this whole thing is 2x minus 1 and this is x, which, yeah, I guess that would be right. If this is 2x minus 1 and this is x, 2x minus 1 minus x would be x minus 1. So that's the way I did it last year. I'm going to try it the way I just checked, because from what I'm seeing, not only can we go this to this, we can go the one side to the whole. So I'm going to try it that way and see if we get the same thing. So we're going to go this side. Stupid pens. All right, so we're going to go x to the whole thing, 2x minus 1. And then, let's see, and since I started on this side, it would be 16 over 14. I'm trying to see what the example I saw, how did they do it? Hold on. X. Okay, all right. Yeah, and they got a different answer, so we'll see what happens. All right, 14 times x is 14x. 16 times 2x is 32x. Minus 16 times 1 is 16. All right, let's just do the double negative again. 32x divided by, subtract both sides. You get negative 18x, yes, equals 16. Negative 16, divide both sides by negative 18. And x equals negative 6. Well, the two negatives cancel out, so you got 16 over 18, which reduces down. 2 goes into 16 8 times, into 18 9 times. So x equals 8 over 9. That is what I got from the other. It's not what I got last year, but it looks like I did it wrong last year. This looks right. Anyway, if you guys have any questions, please let me know in class. Until next time, next video is either going to be review of Module 8, or more than likely, we'll start with Module 9, trigonometry. You guys are going to hate that. Have a good night. We'll talk to you next time.